Hi students, today we are going to solve the fourth numerical problem. 4 point charges QA equal to 2 microcoulomb, QB equal to minus 5 microcoulomb, QC equal to 2 microcoulomb and QD is equal to minus 5 microcoulomb are located at the corners of a square ABCD of a side 10 centimeter. So you can see here a square ABCD whose side is equal to 10 centimeter. So at each corner you can see one charge is placed. At A positive charge 2 microcoulomb. At B a negative charge minus 5 into 10 power minus 6 coulomb. At C another positive charge of 2 microcoulomb. And at D a negative charge minus 5 microcoulomb they are situated. What is the force on another charge of 1 microcoulomb placed at the center of the square? You can see here O is the center of the square where the two diagonals are meeting. At this point O, another charge Q equal to 1 microcoulomb is placed. So the charge which is located at the center of the square is a positive charge of 1 microcoulomb. Imagine an object at the center is being pulled by 4 persons by 4 ropes. What will be the net force acting on the object? A similar situation has come to us now. Very interesting and very easy problem. There are two methods of solving this problem. One is in the CBSE board examination how we have to solve this. Second one, in the competitive examination how to solve this very quickly within 1 second. Both we are going to learn now. First, in the CBSE board examination, systematically if it is asked as a 3 mark or 2 mark numerical, how to do using Coulomb's inverse square law. Okay students, now you will see here 4 charges I have written. QA, okay, located at A, QB which is located at B, then QC located at C and QD located at D I have written. Now the distance A to B or the side of the square is 10 centimeter. Okay, now this middle charge Q is surrounded by 4 charges, hence it will experience 4 forces. 4 forces. Okay, the middle charge Q equal to 1 microcoulomb is going to experience 4 forces, out of which 2 are repulsive due to the positive charges and 2 are attractive due to the negative charges. Now I am going to find only the magnitude of the force. Okay, for that you have to find the distance of the charge Q which is located at O from A, B, C and D. So the distance OA must be equal to OB, must be equal to OC and OD. That distance we require. So for that entire square ABCD, entire square, I am going to apply Pythagoras theorem for the triangle ABC. You look at the triangle ABC. The side AC is the hypotenuse, is it not? So the magnitude AC is the hypotenuse. Hypotenuse square is AC square, must be equal to what? AB square plus BC square. So this must be equal to what? AB square plus BC square. So AC square must be equal to 10 square plus 10 square. So this is 2 into 10 square. There are 2 terms, 10 square terms. So 2 into 10 square. Therefore, what is AC must be equal to square root of the right hand side. Square root of 10 square is 10. So square root of 2 is root 2. 10 root 2 centimeter. Understand that? Therefore OA that is equal to OB that is equal to OC that is also equal to OD. OA equal to OB is equal to OC is equal to OD. All must be half of this AC only, half of this AC. and this must be equal to what? 10 root 2 by 2. So this is 10 root 2 divided by 2, and that is equal to what? 5 root 2 centimeter. So this is the first step of understanding how to do this in the CBSE board examination. We have to find the distance of the charge at the center from the corners A, B, C and D. All distances from the center will be equal, and that is equal to how much? 5 root 2 centimeter. Have you understood this first? Okay. Now we are going to apply inverse square law. Just you look at the corner A. What is the charge placed here is 2 microcoulomb, 2 into 10 power minus 6. It is positive charge. And what is the given charge located at the center is also what? A positive charge. So what is the nature of the force experienced by Q at the center? It will be repelled. This will be repelled by the charge 2 microcoulomb located at A. So it is experiencing a repulsive force, and this force, this repulsive force will be acting from O towards C. So this is pushed towards C, is it not? So I will call it as the force F due to A. F, the force acting on the middle charge due to the charge located at A. Okay. At the same time, you look at the charge located at B. At B, there is a negative charge. There is a negative charge. So this negative charge will try to attract the positive charge of 1 microcoulomb towards it. Is it not? So now the force acting on the middle charge due to the charge located at B. So this is FB. And this is acting from O towards B. It is attracting the positive charge of 1 microcoulomb because they are unlike charges. Similarly, you can see the charge which is located at C. It is a positive charge. 2 microcoulomb is a positive charge. So this positive charge will try to repel the charge Q at the center. Okay, this charge will repel, and this force, repulsive force, is going to act along OA. So this is the force FC acting on the middle charge due to the charge located at C. And then finally you see the charge at D is again negative. This negative charge will try to pull or attract the charge 1 microcoulomb towards itself. So now the force of attraction, okay, the force of attraction acting on this charge is denoted by FD. So totally how many forces are acting? 4 forces are acting on the middle charge. So what is the net force we have to find out? Is it not? What is the net force you have to find out? So for that I am going to find the individual forces FA acting on the middle charge due to the first charge. Similarly FB, FC and FD, and I am going to find the net force. That only is the question. Shall we see individual forces? Okay, so the magnitude of the force FA. So this is the magnitude of the force FA. So this is equal to what? This is the constant 1 by 4 pi epsilon naught into QA. Okay, QA into this 1 microcoulomb. QA into 1 microcoulomb. So this is QA into Q divided by R square. Here I will take the symbol D square because already we have taken R is equal to 10 centimeters. So here I will take this as D. That is OA or OB or OC or OD. This distance from the middle charge to all the 4 charges will be the same. That is 5 root 2 centimeter. Okay, children. So this is 5 root 2. Now this is a D square. Okay, this is a D square. I have written D square. So what is FA now equal to? FA is equal to the value of 1 by 4 pi epsilon naught. You must be thorough that it is 9 into 10 power 9. So this is 9 into 10 to the power of 9 into the charge located at A is what? 2 into 10 power minus 6. So only the magnitude, whether it is positive charge or negative charge, we must take only the magnitude, okay, because we want to find only the modulus, magnitude. So this is 2 into 10 to the power of minus 6 into the given charge at the center Q is equal to how much? 1 microcoulomb, is it not? So this is 1 into 10 power minus 6 whole divided by distance square. So this is 5 root 2 the whole square, is it not? 5 root 2 whole square. This is in, it is given in centimeter also. So this is 5 into root 2 into 10 power minus 2, okay, the whole square. This is 5 root 2 centimeter. So it is 5 root 2 into 10 power minus 2 meter, the whole square we have to take. So FA is now equal to 9 into, so this is 9 into 10 power 9 multiplied by 2 into 1 is 2 into 10 power minus 6 into 10 power minus 6 will become 10 power minus 12, and this is whole divided by 5 square is 25. 5 square is 25 and this is 2, is it not? So 25 into 2 is 50. So this is 50 into 10 to the power of minus 2 the whole square is minus 4. Okay. So now its value is found to be, you can cut this 10, okay, and you can take this as a minus 3 also, okay. 110 you can multiply and you can write this power as what? Minus 3, okay. This is minus 3. So this is now you see here 9 into 2. So this is 9 into 2 divided by, this is 5 into remaining powers you take, this is 10 power 9. This minus 3 will come up as what? This will come up as plus 3, is it not? So 9 plus 3 will become 12. So this is 10 power 12 into 10 power minus 12. So that these two get cancelled. Okay. So this is now 9 into 2, 18. 18 by 5. 18 by 5 is 3.6. So I will take the unit as Newton. So these mathematical steps you can do as you like. Any other shortcuts if you have also you can go by that way. Okay, this is one of the methods. Okay children, now this 3.6 Newton force is acting on the middle charge due to this charge. And you can see that the direction of this force FA, okay, is from O to C. So this is along, okay, along OC. So along this direction OC I will write. You have to understand this is along the direction O to C. Similarly, I am going to find out FB. So FB is now equal to 9 into 10 power 9. Now straight away I can substitute because one step we have elaborately done. So now by shortcuts I can go 1 by 4 pi epsilon naught is what? 9 into 10 power 9 into QB into Q. Is it not? So what is a QB now? QB is what? 5 into 10 power minus 6, only the positive magnitude you have to take. So this is what? 5 into 10 power minus 6. So this is 5 into 10 power minus 6 into 1 into 10 power minus 6 divided by this distance square will become 50 into 10 power minus 4. That will become 5 into 10 power minus 3 again. So this will become 5 into 10 power minus 3. So that this 10 power minus 3 will go up as 10 power plus 3. So that this will become 10 power 12. Is it not? So this is equal to 9 into 10 power 12 into this 5 and 5 get cancelled. So this is 10 power minus 12. So this is equal to 9. That's all, 9 Newton only. It is only 9 Newton. Understand? Similarly, I am going to take now FC. So FC you can now see here what is the force acting on the middle charge due to this positive charge. Okay, so this is repelled along OA. Before that we have found this FB, in which direction it is going to act is O to B. So this is O to B, this direction. Now the third force FC is from O to A, and this charge is repelled by 2 microcoulomb. Is it not? 2 microcoulomb means again the same expression is going to be repeated. Is it not? The same only is going to come. So This is equal to what? 9 into 10 to the power of 9 multiplied by 2 into 10 power minus 6 multiplied by 1 into 10 power minus 6 whole divided by 5 into 10 power minus 3. So this is 5 into 10 power minus 3. So we will get the same value, isn't it? Already we have calculated for 2 microcoulomb. So it must get what? 3.6 Newton. So this is a 3.6 Newton. Okay, children. Next one is what? FD. So the fourth force acting on the middle charge is again what? Attractive. So it is attracted towards the D. That is due to minus 5. Already we have calculated. So now FD must be equal to 9 into 10 power 9 into 5 into 10 power minus 6 into 1 into 10 power minus 6 divided by 5 into 10 power minus 3. So this 5 get cancelled and you will get what? A 9 Newton only. So this is what? A 9 Newton. Now this FD is going to act in which direction? O to D. So this force will be along O to D. And this one will be along FC will be along O to A. Now you see here FA. What is the magnitude of FA? 3.6 Newton. So this FA is 3.6 Newton and FC also is 3.6 Newton. Is it not? Two equal forces are acting but in opposite directions along the same straight line. They will cancel each other. Understand? Similarly, these two forces FB and FD are also having the same magnitude but in opposite directions. FB and FD. So therefore net force, okay, net force acting on 1 microcoulomb charge is F is equal to FA. Okay, this is FA plus FB, okay, plus FB, and this is plus FC plus FD. But you can see here FA and FC are equal in magnitude but opposite in direction. So I can write this is equal to FA plus FB minus FA, because FC is equal to minus of FA in direction. Isn't it? FC and FA are opposite to each other. So I can write this is minus FA. Similarly B and D, FB and FD. Okay, so this is minus of FB. So FA minus FA, FB minus FB, and that is equal to what? 0. The net force is 0. Anyhow, my dear students, in the board examination, if it is asked as a numerical problem for 3 marks, means all the steps we have to write, because stepwise evaluation will be done. But in the competitive exam, when you go by this method, means you will be losing the time. You should not work it out in a paper like this. We should think first what type of charges are given. In the diagram itself, you can see here that these two charges are equal and opposite corners. These two are equal and opposite corners. So the net force, they will cancel each other. Quickly you should guess. Such a practice you should take. Anyhow, I hope this type of problems you have understood well. But one more type of problem based on the same concept will be coming in the board examination as well as competitive. What is that? Unequal charges will be placed at the 4 corners of the square. They will be different. But the method, this method only you will have to follow. I hope you must have understood this well. Fine.